Here I have three illustrated right-angled triangles. We know they're right-angled by the fact that we're given this symbol here to specify a right angle, 90-degree angle. What we need to identify from a right-angled triangle is the longest side. And if I draw a line from that right angle, I have a sort of arrow that points to the longest side in my triangle. Here it is. In maths, we refer to this side as the hypotenuse. Here you can see my triangle has been marked up with the lengths of the two shorter sides. And we can use those two shorter sides to calculate the length of the longest side, the hypotenuse, by using a theory that we refer to as the Pythagoras theory. You might have learnt it in various different ways, but today we're going to look at the method of squaring it, and then square rooting it. By that I mean we first of all square each of the shorter sides. When we've done that process, because we're looking for the longest side, we add those sums together. Once we've found our answer, we will look to square root that answer, and that will give us the length of the hypotenuse. Here you can see my triangle has been marked up with the lengths of the two shorter sides. And we can use those two shorter sides to calculate the length of the longest side, the hypotenuse, by using a theory that we refer to as the Pythagoras theory. You might have learnt it in various different ways, but today we're going to look at the method of squaring it, and then square rooting it. By that I mean we first of all square each of the shorter sides. When we've done that process, because we're looking for the longest side, we add those sums together. Once we've found our answer, we will look to square root that answer, and that will give us the length of the hypotenuse. We're going to do this operation using the calculator, so we need to identify the buttons we're going to use, and that would be this one here, which is the squaring function, and this one here, which is the square root function. So the first thing I'm going to do is I'm going to square 3. And you can see on my calculator that gives me the sum of 9. Clear that, and I'm going to square 5. That gives me the sum of 25. You might actually know those anyway because you know your square numbers. We're going to add those together, so I can clear my functions and add 9 plus 25. Gives me the sum of 34. My final step to finding the actual length of the hypotenuse is to square root 34. Again, another function on my calculator. I press the square root button first, and as you can see, the square root symbol comes up on the calculator display. I key in 34, press equals. Now when that comes up here as the square root of 34, that means the number is going to be a decimal. And to get that decimal, I need to use this function here, which changes my square root sign to the decimal I need. Now I'm going to round my number to 3 significant figures, which means I need the 5, the 8 and the 3. And I look to the next number to decide whether this 3 changes to a 4 or not. And because this number is a 0, I'm going to leave the 3 as it is. So my answer is 5.83, and that's centimetres. I just do a double check because I know I'm looking for the longest side. This number needs to be greater than both this side and this side, and it is, so I'm happy that I've done my calculation correctly. Looking at my second triangle and identifying the longest side, you can see that that measurement has already been given. So I need to use this Pythagoras theorem slightly differently to actually calculate the shorter side that I have here. I have 4 centimetres across the top. I have 9.5 centimetres on the hypotenuse. So the shorter side here I'm going to calculate. I still square the measurement of my sides, and I square the longest side first, because this time I'm going to subtract those two square numbers before square rooting, and that will give me a shorter measurement. So again, on my calculator, 9.5 squared gives me a measurement of 90.25. 4 squared, a measurement of 16 centimetres. Subtracting those two numbers, I key in 90.25, subtract 16, and I have a total of 74.25. My last step again, as always, is to square root my final answer. 74.25 square rooted. And again, whatever that number comes up at, don't worry, just press the S and D button. And there we have our answer for the shorter side is 8.6. Now this 1 here is going to increase by a count of 1 because this number is greater than 5. So my rounding is 8.62, again, centimetres. And my double check is to make sure now this number is less than my hypotenuse, which it is. So I'm happy that I've done my calculation correctly. The answer for the shorter side here is 8.62 centimetres. So calculating my final triangle, I first of all assess whether it's the longest side or the shortest side I need to find, and I can see from this that it's the shortest side. So I'm going to be squaring, subtracting, and then square rooting. So I start by squaring 4.23 and 2.2, and I'm going to subtract them. 4.23 squared is 17.89. 2.2 squared is 4.84. Subtract those two sums. Gives me 13.05. And my final step is to square root 13.05. Press the square root button first, equals, and rounded to 3 significant figures, that's 3.61 centimetres. And my check is I'm looking for a number that is less than 4.23, which that is, so I'm happy I've done my calculation correctly. In my next video on Pythagoras, I shall be looking at how we can use these kinds of calculations in a more complicated exam question. Hidden Pythagoras questions, I call them. For now, you'll find more examples for you to practice in your workbook.